Today we're going to start talking about probability and just the basic probability vocabulary. You should have this note sheet in front of you. And if you notice that this note sheet I've already partially filled out because I felt like me writing all of this down with you was just a time saver. So I'm going to go ahead and I'm going to read it. And then if you just want to pause the video and fill it out, that'd be great. But I recommend not fast forwarding because sometimes I will add in some, extra clue things along the way. So the first thing I want to talk about is what is probability. So probability is the overall likelihood of an occurrence of an event. So what's the likelihood of something happening? That's what probability is, okay? So we have some important probability vocabulary. The first vocabulary word is trial. A trial is a systematic opportunity for an event to occur. So a trial is just something that's going to happen, that's going to cause it to happen. So for an example, like rolling a dice. Me rolling a dice is a trial. I'm testing out when I roll a dice what value I'm going to get. Okay? An experiment is one or more trials. So taking that dice and rolling it 10 times or 12 times or 14 times. So a trial is the actual event, and then the experiment is repeating that event multiple times. That's when I'm testing something. A sample space is the set of all possible outcomes of an event. So in a case, when I'm rolling a dice, the likelihood, the set of all possible outcomes, well, what's all the possible outcomes? Well, I can roll a 1, I can roll a 2, I can roll a 3, I can roll a 4, I can roll a 5, or I can roll a 6. That's what my sample space is. It's the set of all possible outcomes. I can roll one of those numbers on a 6-sided dice. I can't roll an 8 unless I have double dice, but I only have a single dice. So if I look at now what an event is an individual outcome or any specified combination of outcomes. So for an example, an individual outcome, what's the likelihood of me rolling a 3? Right? Or what's the likelihood of me rolling a 2 or 2 and a 5? That's what an event is when I'm talking about something specific. So the outcome is what's going to happen. And if you notice down here, it says what is an outcome? It's an outcome is considered random if all possible outcomes are likely. That shouldn't say is, that should say if. If all possible outcomes are likely. So an outcome rolling a dice, I'm not going to have an outcome of what's the probability of rolling an 8. That's not likely, because I don't have an 8 on a 6-sided dice, so that would not be considered a random event. You want your information to be random because if it's not, then you don't really have good evidence to back it up on. So go ahead and pause this video if you need to finish getting those definitions down, but there's a couple of things we got to talk about here with outcome. And I'll write in red so we can see. So I've mentioned this when we were talking about normal distributions, but probability is expressed as a number from 0 to 1. So probability is expressed as a number between 0 and 1, often written as a 4-digit decimal. Okay? So an impossible event has a probability of 0. So an impossible event has a probability of 0. So for example, what is the probability of me rolling an 8? That's 0. I have a 0% chance of that happening because there's no 8 on a 6-sided dice. An event and I'll say the sum of probabilities of all outcomes in a sample set is 1. So the probability in a sample set, when I'm rolling all of the different types of events and I add them all up, the sample set is going to be 1. Probability has to be between 0 and 1. It's 0 if it's impossible, and then it would be 1 if it had an outcome. Somewhere between 0 and 1. So now let's go ahead and let's talk about different types of probability. So I have what's called experimental probability and theoretical probability. So if I look at experimental probability, it says a probability approximated by performing trials and recording a number of occurrences of the event to the number of trials. So I'm just comparing the number of occurrences to the number of events of the trial. That's what experimental probability is. We go more into theoretical probability. Theoretical probability says if all outcomes in a sample space are equally likely, which means they're random, then the theoretical probability is defined by P of A equals number of outcomes in event A over the number of outcomes in the sample space. So this is really the type of probability we're going to be using in this class. So I would probably highlight this one so my brain knows. And I'm focusing on this probability fraction. Number of outcomes in event A divided by the number of outcomes in the whole sample. So I'm going to go ahead and I'm going to look at this first problem. We're going to see if we can figure it out. It says, find the probability of randomly selecting a red disc in one draw from a container that contains 2 red discs, 3 blue discs, and 3 yellow discs. So I have a container with red discs, blue discs, and yellow discs. What's the total number of discs that I have? Well, 2 plus 3 plus 3 is 8, right? But I want a red disc. So how many red discs are there out of 8? Well, there's 2. So probability is 2. So the number of outcomes in event A, so the event is a red disc, there's 2 of them, divided by the number of outcomes in the total sample space. So the total number of discs, you said, were 8. 2 plus 3 plus 3. So if I clean that up, I get 0.25. So that's the probability of me getting a red disc. I have a 25% chance of getting that red disc when I reach my hand into the container and I pull out a disc. If I look at the next one, it says find the probability of randomly selecting an orange marble in one draw. So I want to select an orange marble in one draw from a container containing 8 blue, 5 red, and 2 orange. So, since I want to draw an orange marble, I'm going to have 2 orange marbles, and I have to divide it by the total number of outcomes in my jar. So 8 plus 5 plus 2 is 15. So 2 divided by 15 is 0.1333. So I have about a 13% chance of getting an orange marble when I have 15 marbles in that bag. Let's look at the last one. Jana sits down to dinner at some point between 6 and 7 o'clock. Assuming that all the time intervals are equally likely, find the probability that she will sit down for dinner during each of the given time intervals. Alright, so from 6:10 to 6:30, that's a 20-minute time difference. So that's event A, which is 20 minutes, divided by the total outcome between 6 o'clock and 7 o'clock, that's 60 minutes. So that's 0.3333. She has a 33% chance of sitting down somewhere between 6:10 and 6:30. If I look at the next one, from 6:45 to 6:55, that's a 10-minute interval. So 10 minutes out of 60 minutes is 0.1667. So she has about a 17% chance of sitting down between 6:45 and 6:55. So go ahead and flip your paper. So we have different types of counting principles. So we're going to talk about this first one. It's the fundamental counting principle. The fundamental counting principle tells me If there are m ways that one event can occur and n ways that another event can occur, then there are m times n ways that both events can occur. So m times n ways. Okay? So one way that we can represent this is by using what's called a tree diagram. A tree diagram is a visual representation of all possible outcomes in a series of events. So if I go through and I look at these examples, I want to draw a tree diagram. So it says draw a tree diagram to represent all possible outcomes for flipping a coin twice, where H stands for heads and T stands for tails. So here I'm standing. I'm going to flip my coin one time. When I flip it this first time, I have two options. I can either get a head or I can get a tail. So now that I'm at my first time, I'm going to flip it again. And when I flip it again, I can either get a heads or I can get a tails. And then down here, I can also flip it again because that's still the second time. I can either get a heads or I can get a tails. So that's what a tree diagram looks like. So my possible outcomes, I can get a heads and a head. I can get a head and then a tail. I can get a tail and then a head. Or I can get a tail and then I can get a tail. So I have 4 possible outcomes. Another way I can do this is I have two different types of outcomes. I can either get heads or I can get tails. And I have two flips. Right? Number of times. 2 times 2 equals 4. That's what this fundamental counting principle tells me up there. That if I have one event that can occur m times and another event that can occur n times, I multiply them together to determine the possible outcomes. But a tree diagram is still also nice because you can count very easily. 1, 2, 3, 4. 4 outcomes. Alright, let's go ahead and let's look at this next example. Henry has 4 shirts, 2 pairs of pants, and 3 ties. Assuming that all of these outfits consist of 1 shirt, 1 pair of pants, and 1 tie, how many possible outfits does Henry have? Draw a tree diagram and then use a multiplication rule for counting. So, alright, so here's Henry. He's getting dressed. He's going to put his pants on first. He can have pants 1 on, or he can have pants 2 on. Then he's going to put his shirt on, so he has 4 options for shirts. Shirt 1, shirt 2, shirt 3, shirt 4. Shirt 1, shirt 2, shirt 3, shirt 4. Now he has 3 options of ties. So every shirt gets 3 options. So I can sit here and write tie, 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 and forever, right? So this value here determines the total number of outcomes. So how many ties are there if you sit there and you count? There's 24. So there's 24 possible outcomes. Another one I can do is I have 3 scenarios. I have pants, I have shirts, I have ties. How many pairs of pants did he have? 2. How many pairs of shirts did he have? 4. How many ties did he have? 3. Multiplication rule says I can multiply them all up. 2 times 4 times 3. 2 times 4 is 8. 8 times 3, 24. Done. So the tree diagram is nice to visually represent it, but I really don't need it because I can just figure it out. Look at the next one. Amy must choose a password for her voicemail system. She cannot use the letters A and Z or the digits 0 and 9. Each letter or number may be used more than once. How many possible combination passwords are there? If the password is 3 letters followed by 3 digits. So it's a total of 6 digits. So these are letters. These are numbers. So, in the alphabet, how many letters are there? Well, there's 26. But if she can't use A and Z, how many letters are there? Well, 24. So she has 24 options to put here because it doesn't matter if the digits use more than once. So let's go to numbers. How many digits are between 0 and 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. But I can't use 0 and 9, so there's really 8. So I have 8 digits here, 8 digits here, and 8 digits here. Multiply it up, you get 7,077,888 possible outcomes. So think about all those people who can actually figure out your passwords and hack it, and how many times they've had to randomly generate 7,077,888 times. That's crazy, but that shows you that's how it works. Go ahead and pause this video, and I want you to try example 4. And when you finish example 4, go ahead and unpause it, and I will go over it. So it says 3 numbers from 0 to 9 are randomly selected. Find the probability that the first number selected is a 5 or a 7, the second is 2, and the third is 3 or 9. So I have 3 possibilities. First number is a 5 or a 7, so that was 2 digits out of how many? 10. Times. Second is 2, so how many digits can you get? 1 out of 10, because 2 is the only option that can be. The next one is 3 or 9, so there's 2 digits that one can be, divided by 10. So that's 4 over 1,000, which equals 0.0040. So you have a 0.4% chance of the first number being a 5 or a 7, the second number being 2, and the third number being 3 or 9. So that's a pretty small chance. Go ahead and flip your paper. Now we're going to talk about what a permutation is. We have 2 last counting principles. These are the 2 heavy hitters. This one is called a permutation. A permutation is the ordering of n objects. So if I have a bunch of objects and I want to order it, I would use a permutation. So permutations, we have to remember, permutations are picky, P for permutation, P for picky, about the order. With a permutation, order matters. In a permutation, I have a nice representation. It's NPR, so n objects, but I'm picking R, so a certain number, is denoted by n factorial over n minus r factorial. So let's review what a factorial is. So if I have 6 factorial, that's just saying 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. 720 times 1 is 720. So that's what a factorial is. So, if I look at what permutations are, there are 8 teams competing in a bobsleigh skeleton race. How many different ways can each team finish? So I have 8 teams, right? First, second, third, fourth, fifth, sixth, seventh, and 8th place. If I look at this guy here, how many teams could potentially get first place? Well, 8 teams could potentially get first place. If you go to second place, you have 8 teams. One's already gotten first place, so how many can potentially get second place? Well, that's 7 teams. If I look at my third place, my first place and my second place are already chosen. There's a total of 8, but the first 2 teams have already won, so how many teams are left to get third place? 6. Here, how many teams are left? 5. Here, how many teams are left? 4. 3, 2, 8, 7, 6, 5, 4, 3, 2, 1. I did too many of these blanks. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yep, just can't count. So notice 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, that's the same thing as 8 factorial. 8 factorial is 40,320 ways. If I look at the next one, how many teams can be awarded gold, silver, or bronze? So there's only 3 potential options that they can win. So, and how many teams are eligible to get gold? Well, there's 8. So if one team already has gold, how many are there potential to get silver? 7 teams. And if there's 7 teams, how many are eligible to get bronze? Well, 2 have already been taken, so that'd be 6. 8 times 7 times 6. Notice that's not 8 factorial, but this is my permutation. This is what 8 pick 3 are. I have 8 teams, and I have to pick 3 prizes, 3 medals. So if I fill it into the formula that's up here, I have 8 factorial over n minus r. So 8 minus 3 is 5 factorial. So this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 times 4 times 3 times 2 times 1. Notice those cancel out. So I'm left with 8 times 7 times 6, which is what I got over here thinking about it logically. And I get 336 ways. If you look at the next one, let's go ahead and let's try this one. You're burning a demo CD for your band. Your band has 12 songs, but you can only have storage for 4 songs. How many different orders can you burn the 4 songs onto the CD? So I start out with 12 songs, but I have to pick 4. 12 pick 4. So that'll be 12 factorial all over 12 minus 4 factorial, which is 8 factorial. You can very easily type this into your calculator. Factorial is under the math button. It's under one of those folders. I do not have the calculator in front of me, but it's under one of the math buttons, and you'll see the exclamation mark. So you could do 12 factorial and then divide by 8 factorial. And in your calculator, you will get 11,880 ways. You can also do permutations in your calculator. How you get this permutation in your calculator without having to do the factorial button is if you hit the math button and then you go over to probability. Notice when you go over to probability, number 2 is NPR. So then you type it in, and then you type in what N is, it's 12, what R is, it's 4. You hit enter, you get your answer, which is 11,880. So I want you to go ahead and try this one on your own and see if you can figure it out. As a friendly hint that there will be 2 different permutations that you have to compute because you're talking about seniors and then you're talking about juniors. So go ahead and read this and try it and see if you can get your answer. When you finish, unpause it and I'll go over it. So it says, there are 12 students in the student government, 7 seniors and 5 juniors, who are conducting an election for 5 officer positions. Senior class president, senior class vice president, senior class treasurer, junior class president, and junior class vice president. How many different groups of officers can there be? So I have 3 senior positions, president, vice president, and treasurer, and I have a total of 7 seniors. So I have 7 seniors, and I have to pick 3. Times, now I have 2 junior representatives, president and vice president, but I have 5 to choose from. So 5, pick 2. So I'm going to type all that in my calculator. I get 4,200 ways. So let's go ahead and keep going. Let's now talk about what it means to be a permutation with identical objects. When I have a permutation with identical objects, all that means is the number of distinct permutations of n objects with r identical objects, if I can spell objects, is given by n factorial over r factorial, where r has to be between 1 and n. Okay? So all that means is when I'm sampling distinct permutations, when I am talking about n objects with identical objects, so flowers with flowers and coins with coins and, you know, letters with letters, I'm going to do n factorial divided by r factorial. So it says Tiana is planting 11 colored flowers in a line. How many distinct ways can she plant 4 red flowers, 5 yellow flowers, and 2 purple flowers? So how I do this is it's 11 factorial, so she's starting with 11 flowers in a line, divided by her distinct numbers. So 4 red flowers, so 4 factorial, 5 yellow flowers, so that's 5 factorial, and 2 purple flowers, that's 2 factorial. So I'm going to type all of that in my calculator and hit enter and get an answer. I get 6,930 ways. If I look at the next one, find the number of distinguishable permutations of the letters in Miami. So Miami has 1, 2, 3, 4, 5 letters, so 5 factorial. Now I have to figure out how many times they repeat. M repeats twice, so that's 2 factorial. I repeats once, so that's 1 factorial. No, I lied. I repeats twice, so that's 2 factorial. A repeats once, so that's 1 factorial. So in my calculator, I'm going to do 5 factorial divided by 2 factorial, 2 factorial. I don't need 1 factorial because it's just 1. And I get 30 ways. So I can rearrange the letters of Miami in 30 different ways. So go ahead and try the next one, which is with Tallahassee. And when you finish, the answer will be on the screen. So the answer for number 3 is 831,600 ways. So I can rearrange the letters in Tallahassee that many different ways. That's what a permutation is. And last but not least, we talk about what a combination is. A combination is very similar to what a permutation is, but the only difference between a combination is that order doesn't matter. So order combinations, it doesn't care about order. So it says the combination of n objects, the combination of n objects taken r at a time is denoted n choose r, n factorial over r factorial times n minus r factorial. Okay? So combinations, the order doesn't matter. It doesn't matter which order they go in. Permutations, it does matter. So here, it says find the number of ways to represent 5 comedies from a collection of 30 comedies at a video store. So if I were to go through and pick my 5 videos, it doesn't matter the order in which I pick them. So all I'm doing is 30 videos to choose from, but I have to choose 5. So in my calculator, I can do 30 choose 5, or I can follow this formula up here, which is 30 factorial over 5 factorial times n minus r, which 30 minus 5 is 25 factorial, which equals 142,506 ways. So I want you to go ahead and I want you to try 2 and 3, and then I want you to pause and I want to see what you get. However, before you get started, there's one problem. Number 2, you got to write add an add-on. It says if 10 books were present. So if I look at number 2, 10 books to choose from, I have to pick 3. So 10 pick 3 is 120 ways. If I look at the next one, How many different ways are there to be awarded first prize, second prize, and third prize in a group of 8 entrants in the contestant? Well, you should have gotten 336 ways because first prize, second prize, third prize, order matters. So because order matters, this is not a combination, this is a permutation. So I tricked you. So you should do 8, pick 3, which is 336 ways. Last one, in a survey of 30 students, 25 students favored earlier opening time for school cafeteria and 5 students opposed it. Find the probability, so you know you're dividing to get a decimal. In a random sample of 8 respondents from the survey, 6 students favored and 2 students opposed. So I know I'm dividing because I have to get a probability decimal. So it says 25 students favored it, but out of my sample, 6 favored it. So it's 25 choose 6 times 5 opposed it originally in the whole sample, but in the given sample, only 2 opposed it. So 5 choose 2. Divided by, how many were all together? 30 choose, and in my sample I surveyed 8 people. So I'm going to type all of that into my calculator and hit enter. I get 0.3026. So these last problems down here, I want you to go ahead and determine whether it's a permutation or a combination. Don't evaluate, you're just going to tell me P for permutation, C for combination, and then my answers will be on the board. So here are my answers. If you have questions, make sure you ask, and then we can keep going.